What is differentiation? Differentiation can be defined as a derivative of a function with respect to an independent variable. Differentiation in calculus can be applied to measure the function per unit change in the independent variable. When do we apply differentiation? Differentiation was applied when determining the increasing or decreasing of a function. It also used when determining the speed or distance of moving object. Other than that, based on our topic, the derivative was used to find the maximum and minimum value of a particular function.
5 subtopics to apply of differentiation. First, related rates. Second, analysis of function 1. Then, analysis of function 2. Applied maximum and minimum. And the last one, Rolle's theorem and mean value. What is applied maximum and minimum problems? The problem of finding maximum or minimum value is called optimization. For example, maximize the profit in a company, or minimize the cost, or find the less amount of material to make a particular. How to solve applied maximum and minimum problems? Step 1. Find the derivative. Let the derivative equal to 0 and find the values of the variable. And the last one, second derivative test. More than 0 is minimum value and less than 0 is maximum value. First, what we need to do is write down the formula of cylinder area, which is 2 pi r square plus 2 pi RH equal to 200 pi because of the surface area already given to the statement. Then replace R with X because the question needs us to express Y in terms of X. So it will be 2 pi x square plus 2 pi xy equal to 200 pi. Then factorize 2 pi to the in front and it will be x square plus xy, and bring the 2 pi to the right side and it will be 100 because of 200 pi over 2 pi. Bring x square to the right side and it will be 100 minus x square followed by another x and it will be 100 minus x square over x. So the answer for A is y equal to 100 minus x square over x.
Question B. Prove that the volume of cylinder is V equal to 100 pi x minus pi x cubed. First, we will write the formula of volume of the cylinder. V equal to pi r square h. We will replace the r and h with x and y. And then we will replace y with the value from the answer question A. And then we will multiply pi x squared with 100 and negative x squared. It will be 100 pi x squared minus x power of 4 over x. And then the final answer should be 100 pi x minus x.
Okay, so for question C, we need to find the value of x such that the cylinder volume is maximum. So we will differentiate the equation that relates volume to x, which will give us 100 pi minus 3 pi x squared. It is the first derivative by using the power rule. Next, we will need to find the value of x where the first derivative is equal to 0. So we know that dv dx is equal to 100 pi minus 3 pi x squared over equal to 0. Divide both sides by pi and we get 100 minus 3 x squared is equal to 0. Next, we will subtract 100 from both sides and divide by negative 3. And then we will find the positive root of that of the value. Since x is a radius, so we will only take the positive root. So x is equal to 5.774 centimeters in decimals. Next, we will need to find the second derivative and perform the second derivative test on this value of x. So we can determine whether it is a minimum or maximum volume. So we will find that dv dx is equal to 100 pi minus 3 pi x squared. We will differentiate it and we will get 0 minus this pi x. Then we will insert the value of x equals to 10 over square root of 3 back into the second derivative, and we get that the value of the second derivative for this value of x is negative 108.828. Since this value is negative and therefore less than 0, we know that this value of x will give us the maximum volume. So we will put back this value of x into the original equation v equals to 100 pi x minus pi x cubed, which will give us the volume of 1209.200 centimeter cube. So the maximum volume of a cylinder with surface area of 200 pi meter squared is equal to 1209.200 centimeter cube with a radius of 5.774 centimeters. So, in conclusion, we can use this applied maximum and minimum method in business, financial or scientific calculations whenever we need to optimize the quantity. Firstly, we need to analyze the problem and derive an equation that relates the quantity to optimize with the variable we want to change. Next, we need to find the first derivative of the equation and find its minimum values where the first derivative is equal to 0. Next, we need to find the second derivative and perform the second derivative test, substituting the extremum values into the second derivative. If the second derivative value will get a value larger than 0, then the value will give us a minimum quantity. Otherwise, if the second derivative is less than 0, then the value will give us a maximum quantity. Finally, we will substitute the desired value into the original equation. We will get the optimized quantity.